It's Mr. Van Dong with week 3, day 2 of distance learning here at Sharpstein Elementary School for 5th grade. And today we're going to be talking about line plots. So you need to be on page 845, chapter 11, lesson 8. Okay, this is going to be the last lesson before we jump into the metric system, which is going to be super cool. Line plots are excellent tools. They look a lot like number lines to start with. The difference is that on a number line is a tool that you use to find answers. We don't use them a lot, unfortunately, with my math. They're excellent tools to show work. They're excellent tools to solve answers, to show skip counting and estimation and stuff like that. But a line plot is kind of like a graph. We're going to use it to show data. So we're going to have to label it up like a number line, and we have to label it accurately with the numbers in the right plot, in the right places. We're not going to put like 1, 2, 100, 1,000, 3. That would make sense. So we have to label it correctly, and then we have to display the data in a way that's easy to understand. So this is all about basically graphing. A line plot's a type of graph. You should have seen them before. I hope you remember them. If you've never seen them before or don't remember seeing them before, panic and run. I mean, no, it's totally fine. So here we go. We're going to get started right away. Reading the first problem. 6 friends. So nice. They shared a foot-long submarine sandwich. This must not have been during quarantine. This is either a story in the future or a story in the past where social distancing was not an issue, because right now, you should not be sharing submarine sandwiches with your friends. Sorry, I got distracted there. So they shared several foot-long submarine sandwiches. The table on the right shows the amount of each friend ate. Make a line plot of the lengths on the table. So again, the question here is not like who ate the most, or like how much did Ben eat and how much did John eat. And it's just show the data accurately on a line plot. And my math, being my math, they already made the line plot for you at the bottom. You have to be able to draw your own, where all I give you is a beautiful straight line, and then you label up the rest correctly. Most common mistake here that's really simple to fix is putting numbers underneath the line without a little hash mark. You need a little hash mark. So in this case, when I look at my table, I see that all of the numbers in the table right here are fractions between 0 and 1. So my line plot only needs the whole numbers 0 and 1. Everything else is in between 0 and 1. Now I need to look at the data points that I have in there. I see 1/3, 1/2, and 1/4. Okay, well, I got to label those now. Should I put 1/2 over here? No, Mr. Van Dong, because that's not where I have it. Good job, yeah. I need to put them roughly in the right place. So 1/2 with a hash mark in the right place would be about right here. Okay. I didn't bother measuring it. It doesn't have to be perfect. It just needs to be about in the right place. Okay, the other numbers I had were 1/4. 1/4 is 1/4. It is right in between 0 and 1/2. So I'm going to put that one right there as well. And those are pretty accurate. Now, trying to put thirds on top of the same line plot be harder than you might think, because you've got these other hash marks here that are making your brain see halves and fourths, and thirds don't play nicely with fourths. So you have to unlearn what you have learned. You have to kind of ignore the 1/4 and the 1/2 as you place the 1/3. And in addition to that, you need to be careful that you put the third on the right side, on the correct side of 1/4, because sometimes kids go 1/3 and sometimes they go 1/3 over here, and that would be one of those is wrong. 1/3 is not just neatly halfway in between these, and that would be technically wrong if you put it exactly halfway in between. So if I think about trying to cut this into thirds, here-ish, just kind of estimate it, and hopefully you'll have 1/3 about right there. Or you can cheat and look down at where they put it in your book. That's fine too. This is one of the only times that my brain actually thinks of the circular pie charts that show fractions is when I'm trying to remember what's bigger, 1/4 or 1/3. It's one of the only times that visually my brain, and I think a lot of other people's brains too. I mean, I'm weird. I don't think I'm that different. Anyway, I think that this is one of the most useful ways to remember what's bigger, a fourth or a third, or 2/3 and 3/4. Thinking about those comparisons, the circle little charts are good ways to quickly draw, sketch, and see what's bigger in those cases and make those comparisons. But enough about that. Let's get back to the data. So our directions are to make a line plot that shows the lengths of the tables. A line plot, once we've got our number line up here, we just need to put a little X for every time above the number for every time it appears in our chart. So for example, how many times does 1/4 appear in the table? Count carefully. You not like missing one or counting one twice is not good. I like to literally either cross them out or put a little dot on them. So twice. Okay, so I need 2 X's above 1/4. I tried my best to stack the X's neatly and to keep them the same size. We'll talk about that more as we see more data on the chart. Okay, and the next number up here is a third. How many times do I see 1/3? 1, 2, 3 times. 1/3 is on there thrice. So I should put 3 X's here. Okay, so 1, 2, 3. Mr. Van Dong, that doesn't look right. I hope you're saying right now. And you should be saying that. Remember, the goal of the line plot is to neatly display data for people to look at and understand. Right now, my X's aren't the same size between 1/4 and 1/3. And if I were to just glance at this and say, hey, which one has more X's above it, a fourth or a third? Your brain would go like, fourth has more because it's taller. And you're right, it is taller, but it doesn't have more X's. So we're not trying to trick anybody. We're trying to make our data really clear. So all our X's need to all be the same size and at the same sort of like plane as they go up here to the best of our ability, just like a kind of a traditional graph. Okay, so here's 1, 2, and 3 X's all stacked up pretty neatly right there. So now I can clearly see there's more thirds than fourths in the data. All right, there's one left, and that one is the 1/2. And there's only one of those. I keep it roughly the same size, keeping it in line with all of the others, just where the first line of X's are. And that's it. Now I've got a line plot. And I could be asked questions about this line plot. They could say, how many more friends ate, 1/3 of a sandwich than half of a sandwich? And I can use the line plot to be like, oh, it's 2 because there's 2 more X's right there. So that's how that works. All right, turn the page. Example 2 is directly related to the same problem, so I'm not erasing this because now we are asked a question about it, and it talks about something called fair share. Fair share. I don't know why people started calling it this. When I was your age, instead of saying fair share, we said the word average. So when your parents are like, oh, he's talking about averages. Yeah, fair share, average. The most technical term here would be the mean average. There's different types of averages. So average means like about the middle or about what is usual. The average 5th graders, this tall or whatever. So average, usually what the type of average we're talking about today is technically called the mean average. And you'll learn more about the median average and the mode average or modal average in middle school. Right now, we're just worried about mean average. And it's not mean like, that's not what it is. I actually don't know what the meaning of this word, how it relates and why it's that, but it's not that kind. But we're related to the fair share is the easiest way to really think about it. So in some ways, some of the people who are best at figuring out what mean averages are like kindergartners because they're very concerned about everyone having a fair share, right? So kids, if you think about it as fair share, it's pretty helpful. Okay, let's read the problem. All right. You can find the fair share or the amount that each friend would have received if they divided the sandwiches up totally equally. So fair share, instead of, 3 kids ate a third and 2 kids ate a fourth and 1 kid ate a half. like everybody gets the exact same amount. That's fair share. That's the mean average. You can find that by adding up all the data points and dividing them by how many data points there were. Again, to find fair share, you add everything back together. This is like if these are the sandwiches, we put the sandwiches back together and we see how much sandwich there is. And then we divide them among all of the friends that ate, all 6 friends, okay? So we got to put our sandwiches back together. So they're going to, and then put them back together, and it'll be kind of gross, but like there it is, and it's back together. And then we're going to share it out equally, and everyone's going to be totally not have lost their appetites, and they're going to eat the fair share now. It's going to be totally fine. Okay, now, I don't know about you, but I would prefer to not like get stuck on the addition of fractions and having to deal with like, oh no, I need to find a common denominator for 4, 3, and 2. Like, well, let's find the least common denominator and change all these. We don't have to do that. Don't do that. Most of the time, you won't have to do that in these problems. The majority of the time, you're going to be able to say what numbers here behave nicely together. For example, do any of the numbers just add up to make a whole? Which ones? The thirds? Did you say the thirds? I hope you said the thirds. Louder for the people in the back. It's the thirds. 1/3, 2/3, 3/3. So I am going to literally circle them and draw a little arrow, and you're doing this too. And you're going to make a note that that is 1 whole right there. And I literally wrote whole, so it doesn't look like an L or like an I without a dot on it or something. That's 1 whole. 1 whole sandwich right there. All right, what other numbers play nicely together? Well, the fourths play nicely together. So 1/4 plus 1/4, that's going to make 2/4. Now, wait a minute here. 2/4. Isn't that a half? It's a half. So I've got 2/4 over here, which is the same thing as a half. And I've also got 1 more half here. So, okay, you and you guys are going to play nicely to make another 1 whole. Oh, they had 2 sandwiches. Okay. I feel like there's a frozen joke waiting to be made here about sandwiches. That's what I was going to say. Anyway, I missed it, and I've said it, and I can't make it later, so I'll try. But, you know. There's 2 holes, and there's 6 kids sharing them. Why do I know there's 6 kids sharing them? Because it said it in the problem, but also there are literally 1, 2, 3, 4, 5, 6 data points. So I added my data points up and got 2 holes. And then now I'm going to divide 2. That looks like 72. There we go. Arrow. I've got 2 holes, and I'm going to divide them by 6 kids. 2 whole sandwiches divided by 6 kids. Now, you can literally remember every division problem is a fraction, and every fraction is a division problem. So we can rewrite 2 divided by 6 as 2/6, and we're done. Every kid eats 2/6 of a sandwich. Mr. Rendon, you could simplify that by dividing the top by 2, and you can simplify it if you divide the bottom by 2, and then you get a third. Yes, that's also true. So we could say 2/6. We could say 1/3. Either of those are correct final answers. If we're like, you know what, I don't really want to do formula math, we could draw 2 sandwiches and be like, here's 1 reconstructed sub sandwich. Here's another reconstructed sub sandwich. And then we think about 6 friends sharing them. Well, if I just think about that for a hot second, what if I just go kind of like that? There's 1, 2, 3, 4, 5, 6 equal parts. So everybody ate 1/3 of a sandwich. You can solve it with a picture too. I don't care. Solve it how you want. But the bottom line is making line plots and then solving problems with those line plots is what I was going to say. Okay, those are guided practice problems. So you're going to pause me here. You're going to do the guided practice problem, and we're going to go over it here in a hot second. Whew. That second was very hot. It was a very warm second. Okay, now you've got your line plot complete. and hopefully you have your fair share and you're checking your work. If you were stuck, then, that's okay too. And now we're going through how to do it again. So it'll be fine. So we've got some juice. Amount of juice. It doesn't really matter what it is. And there's a bunch of fractions, and then we have to plot them on a line plot and find the fair share. So I can see that all of the amounts of juice are either 1/4 or 1/2. So I just need to show 1/4 and 1/2. I do need to show the two whole numbers on either side so I can make it clear where those things are. So I've got a 0 on one side, I've got a 1 on another side. I need to show 1/2 and 1/4. Well, 1/2 is right where, I know, shocking, but a half is halfway in between. And then a 1/4 is halfway in between 0 and 1/2. So now I've got my line plot ready to go. And I need to now carefully, because all these little fractions kind of look the same, don't they? They kind of blend together and look the same. I got to be pretty careful as I go through this and make sure I count the right number of these. So let's figure out how many fourths there are. I'm going to count very carefully. I'm going to put a dot underneath them when I'm done using them. I'm not crossing them out because what if I make a mistake and I can't see them and go back and check my work? It's just a little dot is all you need to do. You're not chiseling it out. It's not made of stone. So how many fourths? 1, 2, 3, 4. 4 fourths. Okay. 1, 2, 3, 4. I was careful to stack my x's up neatly in a row and to make them all of approximately the same size. All right. Now, how many halves are there? 1, 2, 3, 4. Also 4. Okay. So 1, 2, 3, 4. Okay, these are not perfectly in line, but they're pretty darn close. If they were not perfectly in line, you know what I'd do? Erase and do it again. This takes like a second. So there I've got my line plot is donezo. It is a beautiful line plot. It is a work of art. It will be on display at the Museum of Modern Art in New York next week, I'm sure. Now I have to figure out the fair share. To figure out the fair share, put everything back together and divide it equally among your data points. So if we pretend that this is like how much juice each kid drank, whatever, put all the juice together and then say, look, 8 children, you have to share your juice, and we're going to share it out among all 8 totally equally, just like kindergartners would. So I don't want to find a common denominator and risk making an error. I want to look for numbers that speak nicely together. And those 4 fourths are calling my name. They're saying, Mr. Van, look at me. You hear it? Oh, I told you it was coming. So right here, I've got 4 fourths. That's 1/4, 2 fourths, 3 fourths, 4 fourths. That's a whole. Okay, so here I've got 1 whole. And I'm just going to write my 1 like that so it's less confusing. All right, well, what about the halves? Do they play nice together? How many halves does it take to make a whole? Oh, 2. So there's a whole. And hey, there's another whole. How many whole gallons of juice did these kids have? They had 3 whole gallons of juice. So we've got 3 whole gallons equally shared among 8 children, kids, goats, whatever. And therefore, the answer is that every kid gets 3/8 of a gallon of juice. So 3/8 is our answer. This is not a magic trick. We don't actually plug this into a calculator. There's no need for that. We don't need long division. We don't need partial quotients. We need to remember that division is fractions. Fractions is division. Our division? It doesn't matter. Okay, go ahead and work on pages 847 and 848. They've got problems just like this one. You got to make your line plots. Be very careful about drawing very neat, accurate X's as it goes up. It should be like ready to go to the Museum of Modern Art. Just magnifique, beautiful. And then finding the fair share for each of them, similar on the back. With some word problems, some extended thinking. So get to it. You do it. And if you finish early, I think you know what to do at this point. I probably don't have to keep saying that, but that's been like my sign off. So anyway, we'll see you guys later.